everyone, for joining us for another week of In Rhythm's Lightning Talks. For those of you who do not know me, I am Jen Crawford, and I have the pleasure of co-hosting this space every Thursday at 5:15 p.m. Eastern. Lightning Talks are an opportunity for our practice area consultants to give back to the In Rhythm community, help us learn and grow. It can be about a topic that they use on their day-to-day. It could be something that they're passionate with on the side. This week, I have the pleasure of co-hosting this space with William, and he will be discussing Webpack 5. So excited, looking forward to learning and growing. And with that being said, I will hand it over to you, William.
And then live stream. Oh.
All right, I'll get started. I'll leave this camera on the screen just so you can see my face. Let me see if I can.
I highlighted it. You're good to go. Okay,
great. Yep. So hello, everyone. I decided to do my lightning talk on Webpack 5, but specifically the new feature that it has, module federation. So I'll first be discussing my inspiration, why I want to talk about this in the first place. I'll then be giving a history of what has led up to how we share code.
Sorry, William, I muted you. If you can just unmute.
No problem. Yes, so I'll be discussing an overview of module federation. Then I'll give a quick code walk. And then if we have time, I'll dive a little bit under the hood of how the plugin works. So before I get started, just briefly, module federation is a way to dynamically share code. With the emergence of micro front ends, it can get a little bit messy, and shared or common code can tend to diverge. So module federation is a start to resolve these issues. So personally, I won't name names of where I worked before, but I noticed just some rooms for improvement. And this is what inspired me to talk about this. So the website I was working on was huge. Different teams managed different pages on the website. So because of this, the code did tend to diverge. So for instance, when I was updating navigations container styles, I make these updates in a dozen FTL files for the same exact update. And this actually led to a bug. There was no standardized way of sharing the same icon formats. There were 8 common footers across the site that showed very similar content. And this made a simple update very complex. And then also deploying a new version of a library or a component, for example, a header, to be used across pages can take a lot of time. And then along with code diverging, the shared code diverging, with the current micro front end architecture, separate Webpack builds or any builds, they're unaware of each other's configurations and their dependencies. So my experience when I was lazy loading a modal from the navigation bar, I faced conflicts from Webpack configurations across the main page. So the Webpack builds amongst the page did not work as seamlessly together as I would have liked. And at the same time, there was a design library that was loaded several times on the same exact page. And this is because the Webpack builds were not aware of each other's dependencies. So module federation can solve all of these issues, but it's still in its early stages, but worth exploring. So the history of code sharing. Over the years, there have been 3 core issues that we as developers have wanted to resolve. The first being the lack of code reusability, the lack of dependency resolution, or in other words, the order in which we list dependencies, and also pollution of the global namespace. And something worth noting is that when I talk about inline scripts all the way up until like the AMD pattern, these are ways of sharing code like in one particular build. Now that micro front ends have become a lot more prominent, now we're kind of starting over the process of trying to solve all plenty of issues, like I highlighted in the last slide. So with inline scripts, we face all three problems. So this has been around since the beginning of JavaScript. We can't reuse any of this code. We have to worry about the order in which we list out declarations, and every single function or variable pollutes the global namespace. This naturally led to containing JavaScript inside of different scripts. So the bright side of this is that we can share the code or reuse the code, but we don't solve the problem of we have to worry about the order in which we list the dependencies because they depend on each other. And it doesn't solve the problem of polluting the global namespace. So this naturally led to the module object and IFI pattern, or immediately invoked function expression pattern. This was a great step ahead in the history of sharing code. However, it still does pollute the global namespace, but it's a major improvement. So how this works is within an application, though there will be just one global object that pollutes the global namespace, which holds all of your different functions or dependencies that can be used throughout. Then the evolution naturally headed towards CommonJS, which is not a library, it's a standardization organization. CommonJS had to create a way of sharing code on the server. This is how CommonJS originated. Because Node doesn't have an HTML page to consolidate code, they had to come up with a whole new API. And this addresses all three of the core issues. But it is synchronous, and this is not ideal when developing on the browser. Then this naturally led to the asynchronous module definition pattern. And this was a way of CommonJS to transfer the importing and exporting syntax over to the browser. It's also asynchronous, but the one downside of AMD is that the syntax is way too verbose. So imagine there was, in most big websites or applications, a file could have dozens of dependencies. You have to make sure that each dependency is matched up in the same order. So like, imagine define as like an import. You need to make sure the add function is the first listed as well as the first listed in the callback. When the import resolves, all of the code inside this callback is executed. But we don't want the syntax. It'll lead to too many bugs. So we have ES6 module syntax, which I'm sure everybody is familiar with. And the great thing about ES6 is that it's actually built into the JavaScript language, which makes very future-proof. It's asynchronous. However, it's not compatible with Internet Explorer, but there are polyfills that you can use. So all of the different APIs or patterns I listed before are great. We evolved into being able to solve those three core issues, but there were still problems that need to be addressed. So in terms of the second core issue I brought up about dependency resolution, CommonJS is able to, you don't have to care about the order of dependencies imported, like on a file-to-file basis, but within a particular file, you have to make sure to list them out properly. And that's why module loaders came along. That you no longer have to worry with required.js which actually uses the AMD pattern. You have to use the AMD pattern. You don't have to care about the order in which dependencies are listed. Browserify then came later. And Browserify was created just so it could be used on top of the NPM and Node ecosystem. And you also don't have to use the verbose syntax of AMD. Instead, you can use you have to use require.js. And as you probably noticed, when I've been talking about these two loaders or bundlers, you can only use one type of pattern or API to import and export code. But Webpack eventually came along in 2014 so that it can support CommonJS, ES6, AMD, anything you want. It really consolidated everything together, so you no longer have to worry about which pattern you're using. So now on to module federation. So before looking into this topic, I had never worked with anything like it. So it's only in Webpack 5, and it's a way to dynamically import or run code from one build on a page to another. You can configure Webpack module federation from the client or from server-side rendering. And when I mention container, you can also think of this as a build. Also a great thing about module federation is that when one shared module is updated, all of the other builds that consume it automatically get the new version. You don't have to spend an hour at least deploying a new version of a package, then installing. It's all dynamic. And then something else that is kind of core to the understanding of module federation is that each build or container can act as a host or a remote. So whenever a user refreshes the page on a browser, whichever page or build loads after that refresh becomes the host, and it imports its remote's dependencies. So, and also another cool thing is that hosts and remotes, they can have circular dependencies. They can go both ways. And the last thing worth mentioning is that if the remote that the host is importing does not have the dependency it needs for that code, the host will try installing that dependency. But if the host doesn't have the dependency, then the remote will install it. It's just a way of ensuring that dependencies aren't loaded more than one time. So now I will do a quick code walkthrough. I'm just starting up my environments. Okay, so I put together a small app just to show you how 3 different applications can work together. I'll first show you the UI, and then I'll walk through the code. So this application, this website has 3 applications. It has, and you can tell the difference by the port numbers. So there's one application that controls the home page and the contact us page. There's another application that hosts the navigation bar, which is right here on localhost 3003. And then there's also a settings page where you can kind of toggle the dark mode or light mode, which is on port 3002. These are all communicating together. And to show you, to kind of just give you proof that I can, if I update a variable or a dependency in one application, it will automatically update in the others. Hold on, I'm trying to bring my VS Code onto the screen. Here, let me just minimize these. So we have our 3 apps. Let's say I want the default mode to be light mode. That's controlled inside of the settings application. I'll go over to settings, go to default settings. First I'll go back to the home. I'll change the default settings to true, is light mode. Once I save this update is going to automatically be reflected inside of the app. Light mode. So before module federation, it would take a considerable amount of time for these small updates. So now let's go through the code real quick. I'm going to approach this by starting on a host and then showing you how the host pulls in its remotes dependencies. So let's start with the home page. So if I'll go to the Webpack configuration, the nice thing about this module federation, there isn't a lot of configuration like littered all over the place. It's all maintained in this one plugin called the Module Federation plugin that comes with Webpack already. You don't need to install it. So there are important properties to highlight. Every app, all 3 of these apps use this plugin, and they all have all of these properties, except some only have an exposes property, which this one doesn't have, and some have remotes properties. So considering the home page is in the app and it's acting as the host, and it doesn't have any dependencies that any other applications need, it only has the remotes property. We don't have enough time to go over like the details, but I will say that all you have to do is list all of the other applications' names from their names field right here. Then all 3 of the applications share React and React DOM. So in all of these applications, you'll see that I have the same shared property, so that React and React DOM don't have to be loaded more than one time. We need the library key, and then we have this file name called the remote entry. So what this is for is when you build the application, Webpack sees this plugin is being used, and it will actually build out a remote entry. I don't know why it wasn't there, but so it'll bring out a remote entry. It'll build a remote entry file. And what this is an interface for Webpack to be able to just pull in the code it needs from the other applications and preventing it from pulling in more than necessary. So now I'll show you the navigation configuration. So the navigation is never really going to be a host because it doesn't consume anything. All it does is it exposes its nav bar component. And as you can see, we're sharing the React. It's all the same, not much has changed. And now I'll go over to settings. Right now, settings is actually still the remote. I didn't reload the page. So now the settings is the host. So I'll go over to settings. I'll look inside my Webpack config, and I can see that this application is acting as a host, and it can act as a remote by exposing its dependencies. Like we saw before, it's exposing that default settings constant variable. And just like the application config, it also has remotes that's pointed towards navigation, because both applications, settings and app, are using the navigation. And another thing worth mentioning is, yes, most things are all contained within this plugin, but you do need to append, hold on. You do need to append the remotes URLs in the HTML. So this is the settings application, and I'm loading the remote entry file for the navigation, and the same goes for the app. I'm pulling in both of these. You don't have to hard code it in. You can come up with you can create some type of method of injecting the script tags with JavaScript, but I just thought this was simpler for now. And that's pretty much it in terms of the basics. I would love to explore deeper in the code, but because of time, that's all for now.
That'll be our next lightning talk.
Yes. And then that sounds good to me. It looks like I don't have too much time left, but I'll just give you some basics on what's going on underneath the hood of all of this. So right here, if you would like to, at a later time, just click through the links on this slide. It'll bring you to the GitHub source code. But the module federation plugin, it consists of three other plugins. It's just a wrapper for these three: container plugin, container reference plugin, and the share plugin. The container plugin is what is used for remote applications. So specifically, if there's an application in the plugin options that uses the exposes key, you'll see in the source code, there's a conditional. It'll instantiate a new container plugin. If it only contains that exposes key, the container reference plugin won't be instantiated because it's not acting as a host and a remote. So technically, if you have an application that's like the navigation that's only exposing something, you can just use the container plugin. And then it's vice versa for the container reference plugin. An application that's acting as a host once Webpack sees the remotes property in the options, it will instantiate the container reference plugin, which this plugin will ensure that the host is able to import all of those dependencies. And then, which is the opposite of the container plugin. The container plugin goes inside of the application, inside of the remote application, and make sure that there are entry points that the host can then import. So it's exposing those dependencies. And then the share plugin is a lot more complex than the container plugin and the container reference plugin. And it's complex in part because it is possible. Let's say you have two applications that are both using React, but you want to override the React version in that remote container. You can list that React version inside of the shared property array on that host, and it'll override its remote. And there's just a lot of background things that are going on in terms of that. So it could take hours to dive through this code. And here are some useful links. And this was, in conclusion, this was just kind of one direction that the web development world can be taking in terms of dynamically loading different dependencies from different builds. But I would love to hear thoughts from anybody who have read about other directions that the micro front end architecture could be taking. We're still in the beginning steps, just like we were in the beginning steps when we first started using script tags inside of an individual build. So it's exciting. It'll be exciting to see how things play out.